I'm Steve. You can call me Steve. Last time I talked about ethanol as a biofuel and all of the ways that this fails to solve the problem of climate change. Fortunately, it's not our only option. We can use biodiesel. Regular diesel is a hydrocarbon fuel, just like gasoline, only it's composed of bigger molecules. Generally, larger molecules mean a greater energy density. Remember, that's the amount of energy stored in 1 liter of the fuel. In this case, bigger is better. Biodiesel, therefore, is a fuel made of diesel-sized molecules from a biological source, rather than pumped out of the ground. There are 2 distinct ways of making biodiesel, both of which involve a process called fatty acid methyl esterification, or FAME. This sounds like gibberish, but it's not really when all of the letters are explained. This is a fatty acid, this giant unwieldy molecule here. So this is the fatty part, this long chain of carbon atoms. And this is the acid part, this carbon, oxygen, oxygen, hydrogen part. More specifically, it's the H of this COOH that makes it an acid. And acidic things tend to screw up any machinery you put them through. So what we do is we take off the H and we replace it with a carbon, or rather a CH3 group. So in organic chemistry, any 1 carbon group like this is called a methyl. That was the M in FAME. And when you put a carbon group on the end of an acid, you make something called an ester. So we took a fatty acid and we made a methyl ester, fatty acid methyl esterification. In addition to removing the acid, we've also made something that's less viscous. Viscous things don't pour or flow well. And when you're trying to get a liquid from point A to point B with a minimum of mess, for example inside an engine, viscosity is bad. You really want things to flow easily. Otherwise the whole thing gums up. Anyway, the 2 different methods for making biodiesel differ in where the raw material comes from. Generally, you start with an oil. Oils in this case are made of fatty acids bound together with a linker, and you can break up that conglomeration and release the free fatty acids and do FAME. One source is oil-producing plants, such as the oil palm, which sounds like a pretty unimaginative name. In Canada, we grow a lot of canola, which produces an edible cooking oil, which can also be used for biodiesel. However, this is counterproductive, and this will be a running theme in these videos, which is an attempt to make biodiesel, which just makes the problem worse. In this case, we're growing a crop to use as a fuel, and every hectare you use to grow oil palm is a hectare you can't use to grow food. And with 7 billion people on the planet, we need all the food we can get. In addition, in Indonesia and Brazil, they're cutting down the rainforest to clear land to use to grow oil palms. And this kind of deforestation releases CO2. So if the whole point of biofuels is to reduce CO2 emissions, you can see how this wouldn't help. All is not lost, however. There's actually a happy ending to this story. The other method of making biofuels is to use waste cooking oil, stuff that's been through the fryer a few times and is ready to be thrown out. This is another running theme in these videos, using waste materials to make our fuels. We should actually be looking at stuff that nobody else wants as our feedstocks for our fuels. Anyway, this waste cooking oil can be famed just as easily as the other stuff and produces the exact same thing. They actually sell kits online now, and this technology has progressed to the point where people will make fuel in their garage. Running cars on cooking oil won't solve the problem tomorrow. For one thing, despite there being a McDonald's on almost every corner, there's just not enough waste oil to run every vehicle. It's a start, however. Every tankful of biodiesel is 1 tankful of fossil fuels that won't be released. It's a short-term solution that we can implement now, while long-term solutions are being worked out. What are those long-term solutions? That's a topic for another video. I've been Steve for Curiosity by Let's Talk Science. You can find out more about biofuels at www.explorecuriosity.org, or you can watch my other videos at my YouTube channel, Science Isn't Scary. Thanks for watching. See you next time.